Yeah, it's afternoon somewhere. Good morning. Hey, so I'm Paul Yu. I am here in the math department at Grand Valley State University, one of the co-coordinators with my colleague, Dr. Taylor Short. He's the person that you probably got a lot of emails up in terms of the run-up to this. But I'm the person that's responsible for bringing the cookies. So there you go, right?
You said it was the faculty sustenance coordinator.
Okay, yeah, there you go, right? So without Taylor, this conference probably wouldn't happen. Without me, we wouldn't have cookies. So I don't know, we can kind of make value judgments later, but we all have our role, right? So anyway, I'm so excited to be able to introduce Dr. Amanda Jansen,
yeah.
that goes by Mandy.
Yes.
Right, she goes by Mandy. She is a professor of mathematics education at the University of Delaware. And she is a joint appointment in both the College of Ed and in the Department of Mathematics. Before being faculty at the University of Delaware, she got her PhD at Michigan State University. Yep.
Go green.
Yep. So she knows this area. And we had this wonderful kind of nostalgic dinner at Sanchez last night. One of her, someplace that she frequented.
I have been there in the early 2000s, so
yes,
yeah.
Yep. So it was kind of this flashback for her. Before getting her PhD at Michigan State, she got her undergraduate at the University of Arizona, where she's from originally. And when she graduated from the University of Illinois, she was a middle school teacher for a number of years before getting her PhD. Her research interests are motivation and engagement of students and teacher education. And kind of an interesting fun fact about Mandy is she loves pinball, owns a pinball machine, and more specifically, it is based off of the game Roller Coaster Tycoon, right? If you've ever heard of it, right? So without further ado, Dr. Mandy Jansen.
Yay! Thanks, friends, for coming. I have a link to the slides if you want it, and it'll be posted also later, and the link's up here. And if you are on Twitter, I'd love to follow you, so you could follow me. I'm at Mandy Math Ed, and I'm so happy that we could think together today. So I often say to people, I live in Delaware, and they say, that's cool, I really like New England. And I'm like, that's cool, I don't live in New England. So if you don't know where Delaware is, Delaware is like the east coast of Maryland. So it's on this, what we call the Delmarva Peninsula here. And so I live about 45 minutes south of Philadelphia, about an hour north of Baltimore. And it's also the region of the country where our president lives. So that's where Delaware is. And you heard a little bit about me from Paul already. So I teach future elementary teachers, middle school teachers. I conduct research in classrooms, and I do professional development around the state. And everything I know about integrating rough drafts and revising into math classrooms is through collaborating with teachers. I created these ideas together with teachers, and so everything I know is because teachers have tried these ideas out and shared them with me, and then our ideas are growing in community. So you will have new ideas today, and you can share them with each other and with me, and we'll continue to grow in our thinking, revise our thinking about rough drafts. So I think about incorporating rough drafts and revising into math class, phrasing it as rough draft math. Some people will have never heard of this. For some people, maybe you've heard of it before, it rings a bell. Maybe some of you can explain what it is. Maybe some of you have even tried it. And maybe some people feel like you could teach other people about it. So let's let people know where we're at with that. So a closed fist is like a 0. 1 is like maybe. 2 is like you can tell people. So go ahead and share. Cool. So there's a wide range here, and that's awesome, because if you've never heard of it, you're going to have new insights that we're going to all learn from. And if you have thought of it before, you can revise your thinking today. All right. We've seen dot talks. It's something we often do in math class. And as a former middle school teacher, it took me a long time to think about, why are we having people count dots? Like, what's the point of this? And I've come to understand one reason why we have people do dot talks. What we do is we say, look at these dots here. Mathematicians look for structure. They break things up, they chunk it, so you can count the total number of dots. without counting one by one. So we want to think about how we're chunking it, how we're partitioning the image, how we're seeing the total without counting one by one. And so what's powerful about that, specifically connected to drafting and revising, is you can have an initial draft of how you see it, and then you can hear someone else's way, and you can revise your thinking, right? So go ahead and think to yourself, how would you find the total number of dots without counting one by one? How would you chunk the image? Go ahead and think to yourself. Find a partner and share how you noticed the total by chunking the image. And you could be a group of 3 or a partner.
See, we do candle defense on it, so I could immediately see the doubles and then the candle thing. And then, so you did doubles. Yeah, I did double.
Oh, 6 like the square or the rectangle 6, and then a 4 and a 4. Yeah. So I did. And then I saw, but I could have made like a larger rectangle by changing the 7 and 3 to 4.
So one way I'll bring us back together is I'll raise my hand, and then you can raise your hands to then say, okay, now we're ready to come back together. Awesome. So I always think it's interesting that someone can see this completely differently than someone else. So the point here is not the answer, right? It's how you see it and how to be introduced to a new way of seeing. So Paul asked me last night, how do you interact with Twitter? How does Twitter help you professionally? Well, I always learn from other folks when they share their work on Twitter. So this was a teacher who shared how her students were thinking about the dots in this image. And so then they took the image and then talked about how they chunked it. And then they could talk about representing that chunking symbolically in different ways. So this is one student's different ways of representing the image. And you could take the symbolic representations into a lot of different directions, distributive property, things like that. So if you want, you can take the dot talk further and think about different ways of revising how you share the symbolic representation for the quantity. I thought, oh, that's cool. I can use their work on Twitter for my presentation about rough drafts. But the idea here is we're not fixing anything that's incorrect. It's all correct, but it's expanding our ways of seeing the situation by hearing from other people's points of view. So what I'm going to talk about today has 3 parts. Part 1, what do we do to welcome students so they feel free to share their draft ideas when they're not sure? How do we incorporate revising into a math lesson? And what do we do to think about how we can honor strengths in people's drafts and revisions to continue to build that classroom culture? So welcoming rough drafts in math class. Why and how would we do this? Well, one of the things that's very interesting about this phrase, rough drafts, is that a lot of us have experience with that phrase in other contexts besides math. So I start by asking maybe my future teachers in my class or 7th graders that I would teach or any adults or kids, the name has meaning for people. So I have a Padlet that's available to you. You can, in whatever device you have, if you have a phone, you can use the QR code. If you have a computer or a tablet, that you can type in this tiny URL. And I'm going to ask you, why would math teachers do this anyway? You have draft ideas about this yourselves. So why would math teachers incorporate rough drafts and revising into math class? Will you please share your rough draft thoughts about this question? I'm going to go there myself. So like on my phone, there's a little pink plus sign, and I can press that and type things. And I've set it up too that you can like things that other people say with that heart. You can comment on what people say. I can display some of this up here. Ooh. Get different perspectives. Encourage critical thinking. Ease anxiety. Show that it's okay to be wrong. There are lots of ways to do the problem. Freedom to think without being judged. It's how mathematicians do work. Yeah, this is like how mathematicians do math. Helps people build on their knowledge. Takes away fear of being wrong. Embrace the process. Everyone has something of value to share. We talk and write our way to understand. Yes, yes, yes. So read what other people said. You can write comments back to your friends in the room. Mathematics is an art. Like any other piece of art, we keep working at it. Ooh. Would anyone like to comment on what they're noticing and what people are saying, or what they're wondering about what people are writing? Anyone want to share? What are you noticing? Maybe what makes sense to you? What resonates with you? Who could share? Yes?
Feels like it opens the playing field that all answers are acceptable and more likely to engage students to share their thinking.
So it opens things up, and then more people might feel like they should share their thinking because it's more accepted. Awesome, I hope so. What else are you noticing, wondering? What makes sense to you about what you see here? Ooh. Can you say more about that? Beautiful. Yes. I would love it if people realize just because they have one way to solve it and find a correct answer, they're not done learning. You can keep making a new connection, maybe refining, maybe building in a new representation. I think we know from teaching, every time we've taught a problem we've taught before, we still keep expanding our thinking about that problem. So if students can realize they're not done just because they've made it pass through the task, that would be a great insight. Any other comments? Jennifer, I think you were going to say something before?
So it feels, I see a lot of comments that maybe it feels more authentic to process than being a mathematician isn't just completing worksheets. If everyone has to fall in love with the way of thinking, then this is more easy.
To fall in love with a way of thinking. And it feels more authentic of how people engage in the process of doing math. Love it. So this is something that you can do right away with your students. What do you think rough drafts could be in a math class? And they're going to have ideas already, right? We can bring our prior experience with drafting and revising and then connect it to math. Again, I love Twitter. People share what they do with their work. So this is a 5th grade teacher in Illinois. There's a group of teachers in Illinois doing a book study about rough drafts in math class. So she asked her 5th graders, How might you use rough drafts in math? Why might it be helpful to you? And these are what her students said. Well, rough draft math could be just a sketch, just a quick idea. It could be my sloppy copy. It could include mistakes and errors. It's in progress. It's not just for publishing it yet. Give you ideas, give you some time to learn, makes me feel less pressure, makes me feel comfortable making mistakes. We're always going to do things imperfectly. It's not a judgment of how we think. So people will have ideas about this already, right? Oh, rough drafts in math, what could that be? And you can build from there. So I like to think that rough draft thinking is happening anytime somebody is sharing their unfinished or in progress ideas and remain open to revising. Or even if you think your thinking is finished, you're still open to keep growing those ideas. Okay. I think another way to talk with people about rough drafts and revising is to contrast the concept of rough drafting with final drafting. Earlier in my research career, I spent a lot of time interviewing people about what does it feel like to share your thinking in a classroom. Like you're having a math discussion, and why might you participate? Why might you not? And so some students would say that they were nervous to share because they don't want to be wrong, right? But if you're concerned with performing, with being right or wrong, that takes away from talking to learn. One of the folks wrote on the Padlet that talking and writing allows us to keep growing our thinking. So I would love people to think that discussions are a learning space, that we want to talk to keep learning in contrast to talking to perform. So we want to reduce that performance culture environment and want to create more of a learning culture environment. So anytime you're sharing anything, we're not necessarily trying to perform smartness. Let's just assume everybody in the room has brilliance already. I already know everybody in here has smartness. We're going to share our thinking at whatever stage and then keep growing those ideas together. So rough draft talk is like, you're not really sure. Students might say something like, I don't know, my brain hurts, when they're trying to make sense out of something. When something is new to us, we kind of, I don't know, can't quite get the words out type of thing. And you're using talk to work on trying to understand something new. Just the very act of trying to represent your thinking in words, in a drawing, trying to communicate, you crystallize and develop your understanding just by trying to communicate to someone else. Anytime you're trying to understand a concept, talking through it, writing about it, drawing about it can help you develop your thinking. So the idea about using rough drafts in math class, I worked on this with a group of teachers in Delaware. We read chapters from a book called Exploring Talk in School. So we're reading and thinking about how to create an exploratory talk culture in our math classrooms. And most of the teachers thought it made a lot of sense to call this rough draft talk because rough drafts meant something to kids more than maybe exploratory. And then we created ideas together about what we could do to promote rough drafts and revising in math class. And students will pick up on this right away and start to use the term to sort of tag their talk. Like, can I just share my rough drafts? And then they feel like safer, they can label it, they can sort of explain to people that they're not fully forming their ideas yet. People are willing to take this up pretty fast. So what can we do to communicate to students that their rough draft ideas are welcome? I've been following the work of Crystal Kalenic-Craig. She is a professor at the University of Texas, San Antonio, and she learned from a teacher in Tucson, Arizona, named Olga Torres. And Olga, in her classroom, promotes the idea of learners have rights. You can ask students, what rights do you want to have in this classroom? You can introduce a set of rights to start, and then the class can build their rights. But telling the students, in this class, you have the right to be confused. That's just normal, right, for learning anything new. You have the right to say what makes sense to you with words that are familiar to you, with representations that are familiar to you. You can write things in ways that make sense to you. Of course, you have the right to make mistakes. That's just a part of learning. You have the right in this class to share your unfinished thinking and not be judged for it. And of course, you have the right to revise your thinking. And then you can ask the class to build additional rights. So you can create a set of rights of learners with your students. You can also ask the kids, maybe at the start of class, what right do you want to work on claiming today and enacting in this class? And at the end of class, reflect on, how did you enact this right? You can also ask them to reflect on noticing, when did one of your classmates enact their rights today? What did that look like? Something you can build over time. I'd like you to take a moment and collaborate with folks around you and think about this. Of this set of rights, are there certain rights that you'd want to have in your environment? Why? Any rights that you would like to add to this list? We'll be doing some math together in a little bit, and there might be some rights that you want to have. Please discuss. Hi, how are you? Good.
When you go to share, I have some from online chat as
Oh,
well.
great. Could I hear some of your thoughts about these rights? Anyone over here want to share something? Yes.
So we were talking about how we could do a better job being more specific. We could do a better job at being more specific on these rights. I know for myself, when a student says that they're confused or anything, I say, that's okay, let's work on it. And I think that I need to be more obvious of, you have the right to be confused, you have the right to come back and revise your thinking, because if just saying that's okay, then they just think, well, no, it's not okay, you're just trying to be like the nice teacher who's going to help me out, instead of, oh, it's okay, I'll just come back to it and learn more. So that's what we were talking about back here.
So it sounds like you're thinking about persisting past the confusion, and you can draw on another right to encourage them. Okay, if you're confused, then continue to draw on the right to revise your thinking. Draw on that right to revise your or to have mistakes. So it's not just at confusion, right?
Yeah.
That's beautiful. More thoughts about this? Yes, and I'm bringing this microphone for folks at home, I think, right? If they're hybrid. Yes.
So we talked about the idea of having the right of equal opportunity of learning, especially for kids with special needs.
Equal opportunity?
Right.
How did you talk about that? What did you say?
So we have more and more students that come to the classes with special needs.
Special needs.
They also should have an equal right to understand the mathematics in a way that is equitable for them.
That makes sense to them.
Mhm.
That's beautiful. Any thoughts back here about rights of learners? Not really. Yes. Okay, Paul.
So some from online that people have been sharing is the right to be heard and respect for each individual in class, the right to ask for help, the right to make mistakes and redo work, the right to try even if I don't have the answer, the right to collaboration. And once someone responded saying, I love the right to be confused. This particular teacher works with special ed, so that one is very important in that
Yes.
particular context as well.
Thank you. John,
So he's an art teacher.
Oh,
and
awesome.
He was saying that the right to steal.
the right to steal, say more about that. I love it.
Well, like, not steal like an artist. Like,
Yeah.
To find sources and cite them, of course.
And draw
But
inspiration.
yeah, I think so.
I think so too, because maybe your revised solution would be inspired by what you saw from someone else, but then you put your spin on it, right? That's beautiful. Thanks. Would it be okay if I just set this here? Okay, cool. So when I think about culture building practices to welcome rough drafts, I think about explicitly talking with students about what it means to learn, especially this notion of communicating, talking, writing, drawing is moving your thinking forward. That learning, we think about this all the time, how learning is a messy, nonlinear process, trial and error. That's normal. It's not a problem in us that we have to go through trial and error. That's just how everyone learns. So normalize drafting and revising, tagging the talk, like, why don't we just share your rough draft ideas? Teachers tell me that when they say that to the class, it's like letting the air out of a balloon, like, oh, I can just say anything? Yes. And then the students will say, oh, can I just share my rough drafts? And then layering in this notion of our rights as learners really communicates to the students, yes, you do have these rights in this space. And I'm sure you have other ideas of how you create a welcoming classroom culture. So I just wanted to share a few, but this is obviously not an exhaustive list. And you also will have insights about how to welcome drafts. Okay. Yes, we do have time for my activity. So we want to do a revision experience about revising in math class. So one of the newer pieces to me about rough drafts and revising is explicitly putting in moments of class where you have them look at the work that they've done, rethink, and add a revision. So you can do this in multiple ways. So we'll be thinking about that today. I love this image. It shows all thinking can be improved because it's not like, so speaking of art, right? It's not as if one of the butterflies is right or wrong. It's just constant refining, improving, growing, changing. So I want us to think about revising, not necessarily as fixing something that's wrong, but as continuing to grow, expand, and refine. This long list talks about a lot of different goals for revising. Sure, you could make the math more correct, maybe fix a mistake, but you could do other things too, like try to have a new idea, a new way to see, a new solution strategy. Your solution could become more precise, maybe by how you change the words in your explanation, even if it's already correct. You could take your explanation and make it be more detailed. Could already be logically true, but you could expand upon it. Or you can make it more concise. Again, a correct explanation, but maybe you're going to eliminate some of the wordiness. You could become more illustrative. You have a correct explanation, but let's add in a representation to help people see relationships. Mathematicians talk about creating more elegant proofs. Maybe you could create a more elegant argument, even if it was already correct. More illuminating. Often my first drafts in my writing are more for me, and I need to revise it to make it communicate better to others. More convincing. People talk about convince yourself, convince a friend, than convince a skeptic. So a lot of these revision goals could take something that's already working mathematically, but refine it in another way. A middle school teacher in Oregon told me that what this has done in her classroom, she stopped using the language correct or incorrect, and they talk about revising only. They don't judge correctness and incorrectness anymore. They just talk about, I want to revise, because even if it's correct, you could keep going with the thinking. And so she says that once she's dropped the language of correct and incorrect, we don't talk about that anymore, more students are seeming to try in her room. So she made this slide at a share out in professional development, and I thought I would share that. A lot of us use routines in our math classroom in a variety of ways, and I want to go through a routine that maybe a lot of you have seen before, and then think about how we can layer in rough drafting as a way of thinking about that routine, and revising as a way of thinking about this. Some people say, oh, rough drafting and revising affirms what I'm already doing. And so for a lot of us, it's a frame or a way of thinking about our work. It doesn't necessarily mean we have to overhaul everything. You can make small changes, but just think about it through rough drafting and revising. And before we do math, I want to say, in this space, not only do you have rights as learners that we talked about, but we'll share this norm. An 8th grade teacher in Boulder, Colorado said this is his set of classroom norms. That's it. Be brave, be kind. So in this space, we're going to be brave enough to share our draft ideas. We're going to be kind enough to share with each other. And we're going to be kind when we're interpreting each other and assuming what people are saying makes sense to them. So let's think about that as we're doing this work together. I'm going to have us do a 3-act math task that works in an elementary classroom. But we're going to be thinking about 3-act math in the case of how are you revising? So as we do this task, think about different times that you're revising your thinking. So I'm going to have us work on a problem from Kendra Lomax. She lives in the state of Washington. And we'll be doing a task about oranges. So let me get us going. Act 1 of a 3-act math task. We're going to watch a video. You're going to think about, what do you notice and wonder? And what questions can you ask and answer? So think about when I show you this video, what do you notice and what do you wonder? What questions can you ask and answer? You can even think about, once you have the question you want to ask and answer, you can really think about too, like what's a really high estimate for your answer? What's a really low estimate? You can think about information that you already know and what information you might need to know. Okay, let's watch this video. What do you notice? What do you wonder? What questions can you ask and answer? You'll think to yourself, and then you'll talk with colleagues. Woohoo! The sound isn't really essential, it's more the visual. What's going on? I don't know what's going on there. Okay. I'm going to take you right to the end. Try to pause it right at the end, but that's okay. Part of the 3-act math task is that you're just noticing what was happening, and that might be one of the questions that you want information about. So, what questions can you ask about the video? What did you notice and wonder? And then think about information you need to know. Think to yourself. And it's okay if you don't have all the information yet, because you get information in Act 2 that's going to help you solve it. So thinking about more of the questions that you could ask and what information you need to know. Okay, talk to colleagues.
I think so.
Okay, great. Could we get a couple of questions you could ask and answer? Maybe some information that you want. Some questions that you could ask about the video and potentially answer if you had more information.
I can start online while people are thinking.
All right, cool.
So from online, some people were wondering, will each orange have the same number of slices? How many slices would we have if we added another orange? How many slices of oranges are in all? Were some of the wonderings from folks online?
Anybody have similar questions to that or different questions? Yes.
A different question is, was the one orange that we saw field to complete or separated to completion representative? Or was it like really high or really low?
How many kids eat all those?
How many people need to eat, or want to eat oranges?
How long would it take to peel all 10 oranges?
How long will it take? So in the first act, you're thinking about like, what's a question we can ask and answer, and spending time generating that question, wondering about a lot of things. And then as a class, you might be like, okay, let's say we wanted to answer this question of how many orange slices there are in all, but we watched that video really fast. So what information would you need to try to figure out how many slices there were in all? Do you want any other info? You just watched that video pretty fast. So what do you think you'd want to know? Yes?
We actually talked about whether or not they were all the same type of orange.
Yeah.
That makes a difference in the number of slices.
So that's related to this, how many slices are in one orange? Were they the same type? More information you want to know? Yes? You want to see what was at the end of that video? And how does that help us? I can help you out with that. So we thought about what questions we can ask, really high estimate, really low estimate. And if we decide we want to think about how many orange slices there will be in all, you need more information. How about this? So this was at the end of the video. If you have any paper, you could sketch out some of your thinking now. If you have paper, or if you want to do it in your mind mentally, use this information to think about how many oranges there are in all. Orange slices. Thank you for helping me with my precision. You want to think about how many slices there are in all with this information. Think about either how you would do it or how a kid might do it. Yeah, you can talk to people too if you want. So now if I was working with kids, I would circulate the room and I would choose some strategy strategically to share out. And then I would ask people to reflect on if they have suggestions for to try to make sense out of what that person's saying, like how does this make sense to you? And then I could use their thinking. Maybe can I use this to revise my solution? Or maybe through the conversation, that student would want to revise their solution. So if we thought about how many orange slices there are in all, you could strategically choose someone's thinking and treat it as a draft. We revise our thinking when we hear from other people. So you could brainstorm with this student what makes sense to everyone in the room about this student's thinking. So rather than evaluate and think, is it right, is it wrong, assume that it makes a lot of sense. I mean, it does actually, right? And so try to make sense out of it. How does this make sense to you? Take some time, look at their thinking. So what makes sense to you about this student's work? Who could share? Yes.
They're, I don't know if it's, okay, they're using, they're assuming that the future oranges that are peeled are going to be similar or identical to the previous oranges that we've seen.
So there's some relationship from the original peeled oranges that they're being used to think about that relationship repeating. So the 19 and the 19, we're seeing that two sets of oranges have 19 slices repeating that. What else makes sense to you about how this person was thinking? Yes.
He gradually went up, so he knew that each group was 19. So then he first did the first two chunks, 19 and 19 equals 38. So he knew then the next two chunks would be 38. And so then one chunk left is 19. So he broke it up into 3 parts instead of trying to do it all at once and counting it. So he saved his time.
And you can see that represented in the drawing as well. So there are lots of ways to draw inspiration from this student's work. And so then I might ask you to say, okay, how could you be inspired to revise your thinking? Maybe did you have a visual? Maybe did you indicate the different steps of how you chunked it? How can you revise your thinking based on what you saw here? So that's one way to build in revision. Then you want to see what actually happens, right? So the third act, you reveal it. So we'll see unpeeling. Ooh.
The suspense is
Yes. And there's no coincidence of how she set these up, right? With the rows and columns to help you count, right? So then we can talk about how in real life, you don't necessarily are having the same number of slices in every orange, and it doesn't mean that if your solution wasn't exact, it wasn't necessarily wrong, and you can compare and contrast and think about it. So, pretty cool. And you could put these videos maybe on Desmos, and then people can rewatch it if they want, something like that. So, 3-act math, we've seen it before, but how is it related to revising? What opportunities might students have to revise their thinking in a 3-act math task? Check in with your colleagues about that. So for this one, you had a chance to hear from a colleague, and so rather than go around the room, I'll share what some other folks have said about this. So in 3-act math, students have multiple chances to think about the problem situation, so they can adjust their question even as they work, like what question are you asking? They might compare their solutions to each other's, to the reveal, what's similar, what's different, what can we learn from that? They could compare at the beginning if I had collected what's a very, very high estimate, a very, very low estimate, or a realistic estimate, and you could compare your answers to the estimates. They could discuss and rethink assumptions that they were making throughout the work. They could think of other questions they could pursue next. Okay, now that we've gone through this whole problem, what's a new question that you're wondering about related to a related situation? A teacher who teaches elementary school in Oregon, I've been working with teachers in Tacoma Public Schools in Washington, and they were saying, oh, rough drafts and revising, here's what I could just do with my students. I give them the same page I was going to give them before. I just tell them, draw a line down it. And then you can write your first draft on one side. Then we share out. Bring students up to the document camera, talk about your first draft. And then you can have them revise and put their second draft on the other side. Promoting the notion that no matter what you write, you can keep adjusting your thinking, even if your first draft has a lot of strength to it. And then teaching students how to talk with one another. One sentence started that this teacher in Washington State says, I would just like to add to so-and-so's draft. So you're trying to build and collectively generate ideas together. So I just love this idea. It's just the problem you're already working on. Draw a line down the page. Write your draft on one side and your revision on the other. It's important when we're doing this work to make sure we have strengths-based orientation to people's thinking. Because even though we're promoting revising, it's not assuming that things are wrong or that they need to be fixed. They're strengths that we're building upon. So thinking about mathematical strengths, what kinds of mathematical strengths could we notice? How do we recognize them? And when and how can we amplify them? So from the teachers in Illinois who are working on reading this book, this is something that a math coach tweeted out. By highlighting strengths in a draft, students might even feel proud of their drafts. The author of the rough draft is no longer positioned as having an incorrect answer or process, but is making significant contributions to classroom learning. That's what I hope happens when people share their drafts. You could be looking for what's beautiful, what's inspiring in their early thinking. So we should be assuming brilliance in students' drafts, naming mathematical strengths. At this time, think to yourself, what strengths might students have to support their mathematical work? I do not like how I phrased that question. What strengths might students have to support?
Revision.
Yeah, I'm going to revise in real time. That sounds better. So thinking about the 3-act math task, what strengths might students have as they're working on that? You can think to yourself. And then I have students brainstorm the kinds of strengths you might need to work on a problem. And I read this book. It's really great. Strengths-Based Teaching and Learning in Math. Beth Kobit and Karen Karp wrote it, and it's geared toward elementary. And they have several different categories of mathematical strengths you might think about with students. And the strengths that you just thought about might be in one of these categories and not another. So some strengths that you could think about might be dispositional, perseverance, asking questions, being curious. Some might be more about mathematical practices, like using multiple strategies, making connections. How do you organize information? You might have strengths in those areas, and you might be developing strengths in other areas. Or maybe content strengths, like using number sense. So when you're thinking about noticing student strengths, what categories are you drawing from? And what categories do you want to challenge yourself to think about more often when you're thinking about your students? So the work out of complex instruction, or there's a book written by folks in Michigan called Smarter Together. You want to purposefully honor students' strengths. It's assigning competence to students, specifically noting somebody has a strong idea that helps the group learn, and even thinking about a student that might have low status in the room, and then naming those strengths so more students realize that that student has mathematical strengths. Disrupting who is being seen as a smart person, because everyone in the room is a smart person. So how to help us see that? So noticing, recognizing, and amplifying lots of ways of being smart at math. And explicitly talk about what it takes to do these tasks so that there are lots of ways of being mathematically smart. If draft thinking is valuable, then lots of ways of working on a problem are valuable so more people can be seen for the smartnesses they bring to the room. Dr. Imani Goffney is a friend of mine who works at the University of Maryland. And she helped me think about cautious points when using rough draft math. So we need to take care to realize whose ideas we're positioning as being in the draft space and whose ideas we're positioning as being further along and more revised. Pay attention to whose strengths we're amplifying and so forth. So thinking about who's being positioned as having a draft. Make sure you're not positioning only students of color as those who are in a rough draft stage. Or the same students all the time. You want to think about how you're positioning their draft work so you develop productive math identities. And mathematical thinking does not always have to be connected to traditional ways of thinking. Deliberately integrating and valuing new strategies or cultural influences of students' identities that could show up in their problem solving. So what would we want to do moving forward? It's the middle of the school year. It's never too late to do check-ins with our students about how we want to revise and revisit our classroom culture. You don't have to wait until August or September to do that culture work. So you can think about what are some ways you want to welcome students' draft ideas? How can we emphasize growth and improvement in our thinking rather than performance? How can we explicitly invite students to revise their thinking? The only way I learn is when people communicate with me, right? So this is a Google form. I would love for you to share what you thought about today. I like to use this sentence starter for revision. I used to think and now I think. So if you can go to this form and share your thinking with me so my ideas can keep expanding, I get to learn about what you thought about today. So please share. Does the link work? Yay. And if you want more resources, my website has a link to a page with a number of different podcasts and articles. And that's my email address, that's my Twitter account. Thank you so much for being here with me today. Thanks.
Yeah, great. Thank you so much, Mandy. And yeah, my mind's spinning right now.
Oh, cool.
So in a wonderful way. So I know that we are now transitioning to, some of you might, there's another set of sessions, or you could go to lunch. And Mandy has also kind of a follow-up Q&A discussion session in the last in the last rotation, right? So if you have some ideas and you want to engage with Mandy in some more just conversation about and extend ideas, you know, that's what that session's about during session F, right?
Yes.
But again, thanks for coming, and enjoy the rest of the conference, lunch, cookies, and collegiality. All right?
Thank you.